Hey friends, I'd love to get back into American Miscellany. So we're here on page 315 of this grand volume. Nice big book here. It was published in 1865. So the information in here is it's 161 years old, but it's still interesting. It's still historical and scientific. And our next essay number 130, I think promises to be very scientific. It's Lectures on Astronomy number 6 by Professor O.M. Mitchell. This is actually indeed our 6th lecture from Professor Mitchell. And I think over the past 5 lectures, I think we've all kind of discovered that this fellow is a little long-winded, a little pompous, but fun actually, actually entertaining in a very long-winded way. So let's buckle in and get through it. Of course, our last essay was essay 129 on St. Paul's Church in New York, page 315 now of American Miscellany. And here we are at essay number 130. Let's go ahead and learn a little something. Lectures on Astronomy, number 6. All right, Professor O.M. Mitchell, what can you teach us today? A little side note, by the way, at this point, I do believe that this is a direct transcription of Professor Mitchell's lectures. So I like to kind of think of it that way, that I'm kind of sitting in a lecture hall and just listening to this guy go on and on. So, it's nice to have a different voice every now and then. All right, Professor Mitchell, let's have your lecture on astronomy number 6. In the examination which I have thus far made, I have confined myself exclusively to our own solar system. I have announced the great laws by which it is governed. I have attempted to explain the manner in which these laws operate upon the various bodies belonging to it, and to show you how worlds are moving through space obedient to those laws, and yet subjected to the influence of each other. But we are to leave this system, grand as it is, and traverse through regions and over distances which we have not, up to the present moment, dared to conceive. I know how difficult is the subject which I am about to approach, and I approach it with embarrassment. Oh, Professor Mitchell. I know how difficult it is to comprehend these immense distances, these vast periods, and these mighty and innumerable objects in such a manner as may be presented intelligibly to the mind. Still we shall venture upon the attempt. If it were possible to transfer you to the outermost limits of our solar system, and there, resting upon the body of the planet Neptune, we could look backward over the space we have traversed, we should find the sun, which to us is so brilliant and so magnificent, already diminished so as not to appear larger than does the planet Venus now appear to us on the earth. But think not that this diminution is in apparent size will diminish it. But think not that this diminution in apparent size will diminish in like proportion the light which the sun throws out. For if there be inhabitants there, they will receive more light from this diminished sun than could be thrown out by 100 of our full moons. So it is still daylight to them. But if objects are diminished by accomplishing this journey through space, 3 billions of miles, what do we see when we attempt to cross that mighty gulf which still separates us from the nearest fixed stars? It is across this almost illimitable space that I wish to carry you. The unit of measure with which we have gone through the examination of our system has been the distance of the Earth from the Sun, the radius of the Earth's orbit. In making our measurements, we must adopt a different unit, for this is too small, and we propose to take as one unit of measure the distance to the nearest fixed stars. With that unit, if we can attain to the knowledge of its value, we shall proceed to measure the universe by which we are surrounded. First, then, let us attempt to explain what is meant by parallax. For this term I shall employ frequently in the course of my remarks. The parallax of any body is the apparent change in the place of that body, occasioned by a real change in the position of the spectator. If I change my position in this room, occupying that of yonder individual, I find every other person apparently to have changed his place. This is a parallactic change. As you have, while sitting in a railroad car passing through the borders of a forest, fastened your eye upon an individual tree, and have seen the others apparently whirl rapidly around it, so is this apparent change in the position of the heavenly bodies. Now, the question is this: is it possible to determine any change in the place of the fixed stars occasioned by a change in the place whence they are seen? If this can be done, measured, appreciated, and determined, then knowing the distance which separates the 2 points of observation and the amount of change occasioned by the change of place of the spectator, we find without difficulty the distance of this object. When the followers of Copernicus announced that the earth revolved about the sun in a mighty orbit 200 million miles in diameter, moreover, that the axis of the earth upon which it revolves once in 24 hours was ever parallel to itself, and still further, that this axis prolonged to meet the celestial sphere was the north pole of the heavens, the objector at once said, "It is impossible, because if the earth's axis, being produced to meet the heavens, touches it in a particular point, this point carried parallel to itself around a mighty orbit of 200 million miles diameter will cut in the heavens a figure having also the same diameter, and certainly this circle described in the heavens will be visible to the eye." But it is not visible to the eye. If the whole diameter of 200 million miles were filled by a globe as brilliant as our sun, at the distance of the fixed stars, it would shrink absolutely into a point which no micrometer ever made by man could measure. Here there was a sort of indicative knowledge with regard to the distance of the fixed stars. It must be so great that the whole earth's orbit, viewed from them, would shrink into an invisible point. So soon as telescopes were perfected and the division of the circle obtained in the most accurate manner possible, by means of which the most delicate observations could be made, the human mind again returned to this grand problem and attempted to pass these hitherto seemingly impassable limits to measure the distance of the fixed stars. And now let me attempt to explain one of the methods adopted to accomplish this grand object. Suppose it were possible to erect in the center of this room a rocky pier going down through the base upon the solid rock itself, so as to be perfectly immovable. Now then, upon this rocky pier, let me adjust a telescope of the highest possible capacity, and let the axis of that instrument be erected so as to have a direction exactly vertical. Having accomplished this, let me screw it to this rock, so that it shall never move, but be forever permanent. Now, to determine the exact axle of this telescope and to make it appreciable, let me fix in the focus 2 most delicate lines of a spider's web, which are so very fine that they may be regarded almost as invisible mathematical lines. Let them intersect each other in the axis of the telescope, and their point of intersection upon looking upward will give a precisely vertical direction. Now I have a piece of machinery prepared to make my examination of a few of the fixed stars, to determine whether there be any change from the fact that the Earth is sweeping round in its orbit. Place the eye to this tube and watch till some particular star that you may have selected, and which lies exactly in a vertical direction, passing through the zenith, shall reach precisely the center point of the telescope, so that the line of vision, like a prolonged axis, pierces the star exactly. Now we record the observation which is made at a particular hour, and when the Earth shall have rolled round its axis and brought it to the same point, we observe it again, and so through the whole year. Now then, if there be no change, that star will ever pass at the same moment exactly through the same point across the axis of the telescope. But suppose it should deviate a little from the point of intersection, and at the end of the year it shall have described a minute orbit, the center of which is the central point where the axis of the telescope pierces the heavens. The magnitude of this little orbit, accurately determined, is the amount of apparent change occasioned by the revolution of the Earth in its orbit, and this would be the parallactic motion of the star. This method was adopted by one of the distinguished astronomers who attempted the resolution of the problem of the distance of the fixed stars. He did not succeed. It defied his ingenuity. Still, he was rewarded in his efforts, if not by the attainment of the object to be accomplished, at least by others equally important. He found the star upon which he fixed his eye moving, not as he supposed it must move, in parallactic change, but taking a different course. For a long time, the cause seemed to be wrapped in impenetrable mystery. But he finally found it to be due to the fact that the Earth was moving with a certain amount of velocity, and light also was coming with a certain velocity, and the two forces combined gave to that star an apparent motion, which, when the cause was known, was perfectly explicable. He discovered in this way the aberration of light, and also a certain other change shown by the fact that the Earth's axis is not precisely parallel to itself, but owing to the influence which the sun and moon exert upon the protuberant matter around the equator, it is made to vibrate, as it were, through a very minute arc in the heavens. This is called nutation, and these two great discoveries were made in the effort to resolve the problem measuring the distance of the fixed stars. I desire to trace up the history of this examination, to show how science has progressed and how art has been gaining one victory after another, even when it seemed to be impossible to make the slightest progress. I pass rapidly down to this second great effort made to determine the parallax of the stars. Galileo had even projected this plan, but never found himself in possession of instruments requisite to make the examination. The plan is simple and will be easily understood by all who hear me. In examining the heavens, we find among the fixed stars certain ones that appear single to the common eye, but when examined with a powerful instrument, they are found to be composed of 2, 3, 4, and sometimes as many as 6, clustered together so closely that to the naked eye they appear as a naked object. Now, after Herschel commenced his review of the heavens, he found these clustered stars scattered profusely, and the idea occurred to him that the apparent near proximity of them was occasioned by the fact that one was sunk in space far deeper than the other, and the visual ray passed near or exactly through the least distant one. In case this hypothesis might be received as true, these double stars, in which one of these objects was double the size, and in this sense appearing to be half the distance of the other, would furnish a most admirable means of determining whether any parallactic change took place in consequence of the revolution of the earth. Suppose I am so situated as to occult any object in this room by one of the columns before me, by throwing my head slightly to the right. Really? All right, let's imagine together. Let's imagine Professor O.M. Mitchell here. Okay, here he is. Professor Mitchell. Suppose Professor Mitchell is so situated as to occupy any object in this room by one of the columns before me. By throwing my head slightly to the right, the object hidden will appear to come out on that side, or by throwing my head to the left, the same object will appear to come out from the other side. Just so in these minute double stars. If the observer start from one extremity of the Earth's annual orbit and find this minute star on the right-hand side of the larger one, if he come around and continue his observation till he reaches 1/4 of the whole circumference, when he finds it is hidden behind the larger star, if you reach the other extremity of the circuit and find how the minute star is coming out on the opposite side, if moreover the change occur every time the Earth makes its annual revolution, it will demonstrate most conclusively that these changes are parallactic and occasioned by the fact that the observer is sweeping around in the Earth's orbit and viewing the objects from different positions. Such is the nature of the investigation undertaken by Herschel, and there seemed to be every reason to believe that he would be successful. But did he succeed? No. He found that these stars were moving, and here again were his efforts rewarded by one of the most brilliant discoveries ever made. He found in these closely united objects that there was a motion, but not of the kind he anticipated. He found that the one was moving about the other, and on a better view, and that they were both revolving about the common center of gravity. Is it possible that these distant orbs were energized by the same kind of influence which operates on the Earth's surface, and that this law of gravitation, extending over this immeasurable gulf, seized these suns and held them obedient to its control, causing them to revolve about each other? The announcement that these motions were going on filled the astronomical world with astonishment. It seemed that a new field was suddenly disclosed, which promised to be interminable. If these stars, so profusely scattered and so closely united, were really double suns, then had astronomy only begun in its career. If to find the periods and measure the orbits of the planets had occupied the attention of the human race up to the present time, how much time would be necessary to measure the periods and determine the orbits of these mighty suns sunk so deeply in space? But the effort has been made, and it is progressing. A solitary object, one of a beautiful system, was taking up, and measures made year after year, till finally a sufficient amount of data are obtained to commence the computation of the elements of the orbit. But what law shall be adopted? The law of gravitation is applied, and, wonderful to relate, these far distant suns are subjected to the same law that carries our Earth about our sun. And now such is the knowledge attained with reference to these various systems that we are able to tell their very position and periods, as we do with regards to the planets belonging to our own system. But up to this time, recollect, we knew nothing from the investigation with regard to the distance of these objects. To this wonderful discovery I shall once again refer. But for the present, permit me to pursue the history with reference to the determining of the parallax of the fixed stars. When it was known that this method could not be successfully adopted, it seemed that the last hope was gone, and there could be no other plane more likely to end in success. Maybe that means plan. Maybe they mean plan there. Okay, but the skill of the artist had not yet been exhausted. In all preceding instruments, it seemed there was difficulty owing to the fact that the micrometer measured with accuracy small distances but failed in larger ones. Finally, of late, an instrument was invented by Fraunhofer, which measured with equal precision both great and small distances. It was called the heliometer. This new magnificent instrument was placed in the hands of a distinguished astronomer, one of the most illustrious men that ever graced the earth, and one better adapted to its use as well as to the critical examination of the problem than any man then living. He was urged by the great man with whom he was associated to undertake this problem by the use of the heliometer, hoping this way to obtain a series of observations that might render it successful. A few years since he commenced his observations. Sorry, you know what? That doesn't seem like a complete sentence, but if this is a lecture, maybe they didn't catch all the verbs. I don't know. Okay, but the query arose: was there among the myriads of stars some one object that would be more likely than all others to yield to his investigation? How could a choice be made? What process could guide him? Let me tell you. By comparing the places of fixed stars determined by ancient astronomers with those determined recently, it is found that those objects which are called fixed are not really so, but are changing their places by slow and almost imperceptible degrees, so that at the end of 2,000 years there is a manifest parallax among them. In later times, after the observations of other astronomers were compared, it became manifest that there was scarcely a solitary star in the heavens absolutely fixed in position. But if this were true, inasmuch as the sun was one of the fixed stars, is it not possible that it too is sweeping through space? This was a wonderful idea, truly. Now, this apparent change among the fixed stars might possibly be accounted for upon the hypothesis that the sun swept through space, carrying the earth and all the planets with it, and thus caused these objects to change their apparent place among each other. If this hypothesis were adopted, those objects which were moving most rapidly would be among those nearest us, and most likely to yield results. Again, he chose to select a double star because if he could find a set which was united in a particular way, he would be able to measure it with more accuracy. He would be able to measure with more accuracy the change that took place in the center of the line that united the stars than in any other way. He selected from the constellation of the Swan, double star number 61. And commenced his measures upon the position of the center of the line joining the two. He referred the central point to the intersection of this line with another perpendicular to it. Here he had to fix a point to which, with the utmost possible precision, he found it practicable to refer that point to ascertain whether any change was going, which should be due to the motion of the earth in its orbit. A year rolls round of unintermitted observation of the most accurate kind. He forms his series of places, notes every object, and finds to his infinite delight there is yet a certain amount outstanding, which upon examination depends upon the position occupied in moving around the Earth's orbit. He does not venture to announce the discovery. He waits till he has repeated these experiments through the following year, and to his inexpressible satisfaction, he finds the same series occurring precisely in the same order as before. Night after night and month after month, he watches this point and again compares the computation of the place and finds the same changes precisely as in the preceding year. The conclusion could no longer be resisted. The mighty gulf had been passed. The distance of that object is known, and its parallax is determined. And now, how shall I tell you the distance? If I speak of millions of miles, it only confuses the mind. Let me use a different unit of measure. I have already told you that light flies with a velocity of 12 millions of miles in a minute. Now then, in order to reach us from this star in the constellation of the Swan, which we suppose to be the one nearest, it must be in its flight It must in its flight take 10 long years to reach this planet, and this is the nearest of all the fixed stars by which we are surrounded. Here then is our unit of measure, and if I have succeeded in carrying you to this point, our course onward is easy. For the moment we know the distance of one of the fixed stars, we feel confident that we can attain to others, and so onward and onward. Indeed, this has been literally the case. Since I reached your city, I have received intelligence from Struve that he has determined the parallax of 7 new stars. Although we find differences in these distances, we have reason to believe the average distance cannot be less than that of the number 61 in the Swan. So soon, then, as we have ascertained the sphere which is described in order to reach the nearest of these bodies, the question arises, are the stars scattered equally through all space? Is there any aggregation of those united by masses? Is there any law which governs these exceedingly distant bodies so as to make clusters in particular quarters or regions of space? If we look out upon the sky, the eye is at once arrested by a beautiful belt of light that sweeps over the whole heavens, called the Milky Way. This, on examination, we find it to be studded with millions of objects extended entirely around, forming a mighty zone of congregated stars, which takes this particular figure. Let us attempt to analyze this figure and see whether it be possible to reach the uttermost limits, and know precisely the point by which it is circumscribed. To accomplish this, we must make use of what is called the space-penetrating power. All I have to say on this point will depend upon the manner in which I shall be able to tell you the meaning of that term, for when we have measured the distance of the fixed stars, it seems impossible to go beyond that distance accurately, yet it is done approximately by this space-penetrating power of the telescope. If the pupil of the human eye could be expanded to twice its present dimensions, it would receive light sufficient to enable it to penetrate twice as deep into space. It is found that it can now see a star of the 6th magnitude, but this does not give an exact idea of the space-penetrating power of the eye because the distances are not in the exact ratio to the amounts of light. A star of the 6th magnitude is 12 times more distant than one of the first. The human eye is capable of penetrating into space 12 times as deep as the line that joins it to the nearest fixed star. If we could increase the diameter of the pupil and make it twice as large, it would see 24 times as far. Now, if we aid the eye by the telescope, it may be approximately done. How shall we determine this relative approximative power? I answer, By the diameter of the pupil, or the object glass of the instrument, we can arrive at a very accurate measurement with regard to that matter. Allow me here to make a very familiar illustration. Suppose upon a level plane, indefinitely extended, it would be possible to erect posts a mile apart. On each of these posts, I will place a board which contains a sentence in a given sized letter. Now, the first one is just visible to the eye, so it can be read at the distance of 1 mile, but to read the next one is impossible. I, however, provide myself with some assistance. I take a telescope and find that with it I can just read the sentence written on the second post. I take one with a larger object glass and read the third, another larger still, and read the fourth. Thus, I will always know the space-penetrating power of the instrument with which I read any one of the distances. And here is the principle. It is in this way we are able to penetrate from one to another depth, and to know what is the radius of the mighty sphere of which we are making an examination. The first question is, whether it be possible to penetrate through the depths of the Milky Way. Herschel attempted this again and again. He takes a spot just visible to the naked eye and with a low magnifying power begins his examination. He finds this spot showing hundreds of stars, and behind them appears to be a milky whiteness which indicates other stars more remote. He takes a telescope of larger power, and this causes the spot to blaze with more stars, yet still there is a milky haze, indicating that he has not yet penetrated the utmost depths. He takes another one, still more powerful instrument, and yet does not attain the outermost limits, for still there is a haziness beyond. Finally, he places his 40-feet reflector in the direction and then finds the whole to glow with beautiful objects like a diamond point. Finds the whole to glow with beautiful objects like diamond points upon the deep, clear vault of heaven, without a stain beyond. Now he knows he has penetrated to the outside, and he knows how much power was required to take him there, for he has gone onward step by step till the last haze is removed. I have had occasion to go through the very same examination, and I can give not the slightest idea of the feelings produced when, upon opening the full power of the telescope, I looked entirely beyond the limits of the Milky Way and saw these orbs resting upon the deep, untainted blue of heaven. Well now, what is the depth of these strata? We find it impossible to gauge it. We throw out the sounding line, as Herschel calls it, in every possible direction. He has done it, and the prominent part of this particular spot extends to such a depth that there must be a series of 500 stars, one behind the other, and each point is remote from the other, as is the nearest fixed star from us. Such is the depth of these objects. Now we are able to measure its figure and tell its dimensions. This has been done. I will not delay the audience by going through any explanation of the manner in which it was accomplished. Having determined the figure of the Milky Way, the next point is this. When we stand out upon the outer circumference of this mighty circle, what is beyond? Is it possible that there is anything beyond, or have we reached the ultimate limit? I answer, we have not reached it. When we look out upon the heavens, we find not only hundreds, but thousands, and with the aid of the telescope, tens of thousands of islands, all as magnificent as this mighty cluster with which we are united, whose suns number hundreds of millions. Now, can we tell anything about their distance? Can we locate them in strata as we locate the stars belonging to our own system? I answer yes, it is easy to estimate with a given sized aperture to any instrument how far it will discern a star of the first magnitude. In case it be removed till it is just visible through the great 54-feet telescope of Lord Rosse, it is ascertained that the distance is so great that its light will take 60,000 years to bring its flight to us. Remember, this is one solitary object, a single star. Suppose it were possible to gather up the constellation of Hercules, which is another universe somewhat like our own, and so near to us that by the aid of the ordinary instrument it is found to be composed of brilliant stars. Let us move it backward and backward till the mighty eye of Lord Rosse's great telescope just loses sight of it. Where think you it will be? I am almost afraid to tell you the distance. It actually overwhelms the mind. It gives such an idea of infinity that it seems impossible to comprehend it. 30 millions of years will it require for the light to wing its flight before it can reach this earth. Such are the distances we are permitted to penetrate into space. I have had the opportunity of examining a large number of these magnificent objects with one of the finest instruments ever mounted. We find among them every possible variety of form. We find these clusters sometimes in a globular figure, occasionally forming a ring of light, as the Milky Way, and in short, in every possible fantastic shape imaginable. And still they are all governed by one law, all subject to the influence of gravitation, and their stability is perfect. I have spoken of the distance of the stars. I intend now to carry you along with me and give you an idea of the periods of motion among these mighty objects. We know that the stars which compose our system are fixed. We are not fixed. We know that the stars which compose our own system are not fixed, but moving. And we have reason to believe that these remote objects are energized by the same principle. We find, moreover, these mighty clusters seem to be scattered through space, not indifferently, but by a certain law. It is strange that a certain stream of them happens to occupy a position nearly perpendicular to the direction of the Milky Way itself. Now, when we return home again and commence an examination of our own system, we have to start with more minute, smaller periods. We find among double stars some moving swiftly. In Hercules, there is one whose motion is so perceptible that you can observe the change after a few nights. It performs its revolution in 37 years only. There is another in the Northern Crown which completes its revolution in 42 years. Then we are carried by analogy still further to the constellation of the Lion, where there is a quadruple set formed by two sets of double stars. One of these revolves in 1,000 and the other in 2,000 years. And inasmuch as the whole four are sweeping by their proper motion together through space in relative company, there is every reason to believe they constitute one system. And in case that be true, the motion of one of the double sets about the other cannot be less than 1,000,000 years. Thus immense are their periods. But what is this compared to the vast circuit of our sun itself? In the course of lectures previously delivered in this city, I attempted to show to those who had heard me how it was that Medler had recently determined the central point in our great stratum, or the source about which all the stars, including our sun itself, are performing their mighty revolution. Now, although we cannot rely implicitly upon all his deductions, yet that he has made a close approximation is certain. And in case we adopt his theory, it requires our sun no less than 117 millions of years to complete its orbit about this grand center. If we then desire to have the measure of eternity, it seems that it is possible almost to accomplish it even here in time. For let us suppose the 100 millions of suns to be united under the action of that almighty power that started them in their orbits. They sweep on, and 117 millions of years roll round before the sun accomplishes his mighty journey. To bring them all back again to the same precise position, if the ratio is anything like what we suppose it to be, taking the single revolution of our own sun and solar system as our first unit, then indeed will we run round literally to infinity and throughout eternity itself, before we shall have accomplished one great revolution, one mighty year. If there be anything, then, that can lead upward to the contemplation of the attributes of him who sustains all things by the might of his power, it is the understanding of his works above. If you would know its glory, examine the infinite number of mighty suns that blaze above us. Multiply the 100 millions with which we are associated by the thousands of other systems beyond us, and compute the result. But again, if you would have an idea of the eternity past, call to mind the thought that all has existed so long. The objects which he has created we know to have existed millions of years ago, for we know with certainty that they must have been created thus early, else their light could not have traversed the mighty distance which separates us from them. And if we would have an idea of his omnipotence, let us remember that these mighty lights are but the expression of his will. Take our own little earth, which is now in comparison with the universe but a grain of sand. If all the inhabitants that ever moved on its surface could unite the sum of their physical strength into one arm, and that arm should attempt to project this earth, it could not move it through a single foot in 1,000 years. Yet God has moved it 68,000 miles since I have been speaking. This is nothing. Remember this, that some almighty power is swinging not only this earth, but all the planets of our system at the extremity of a radius of 100 millions of miles. And not only these, but the 100 millions of suns which cluster in our own system are performing their mighty revolutions. If there be not a conviction of omnipotence here, then it is impossible for the human mind to comprehend it. And we may go a step further. If we would have any idea of the omniscience of God, let us for a moment reflect that there is not a solitary particle of matter throughout the universe that is not operating to disturb the movements of every other particle. The astronomer has shown the most transcendent genius in computing the perturbation of a very few little bodies belonging to his own system. But God has computed the perturbation of every body in the entire universe, and he knows precisely how much influence is exerted by every one upon the other throughout the ceaseless ages of eternity. He knows full well that this mighty system, which he has calculated with infinite wisdom and skill, is so arranged that it shall be perpetual, that it shall never end. But the lecture, thank God, has ended.